Okay, hey guys, today we're going to be doing a quick lesson on how to convert between moles and moles. I know it's the same word, but by the end of this video, you'll be able to convert between moles of a reactant, so the things that go into a reaction, versus the moles of the product, which is what is produced by the reaction. And this is called the theoretical yield. So let's first define what a mole ratio is. Because we need a mole ratio in order to be able to convert between moles and moles. So let's break this down. A mole is a standard scientific unit for measuring. So a mole is just a standard unit of measure in chemistry. We like the mole. But a ratio that shows the relative sizes of two or more values. So you should have seen this in math class before, but in case you have not, we have a quick example. This is not a chemistry example, this is just a ratio example. So, the first question says, for every 4 girls in class, there are 6 boys. What's the ratio of boys to girls? And then once you've figured out that ratio, if there are 12 girls in the class, how many boys are there? So what I want you to do is I want you to pause this video, try these questions yourself, and record your answers onto your Google form. Okay, so by now you should have finished this question yourself. So we're going to go ahead and go over the answers. So for every 4 girls in class, there are 6 boys. What is the ratio of boys to girls? So a ratio we set up such as this. We have boys, and then this semicolon here, this means 2. So I know that I need to set it up with boys, 2 girls. Perfect. So erase this. That looks terrible. Perfect. So next, all we need to do is fill in our numbers. So it said we have 6 boys and 4 girls. So this is technically the ratio. The ratio is 6 to 4. Boys to girls. But we can simplify this. How could we simplify this? Like reduce this ratio. Right, we could divide both by 2. Giving us 3 to 2. So the final answer is the ratio of boys to girls is 3 to 2. So now that we have this ratio, we can answer question 2, which is saying if there are 12 girls, if there are 12 girls in the class, how many boys are there? So we have our ratio, which is 3 to 2, and it just told us that we have 12 girls. So I'm going to put 12 here. And then I'm just going to leave this a question mark. This is what we're trying to figure out. We're trying to figure out how many. So I'm going to set it up how I always set up anything when we're converting between one thing and another. So when we convert from grams to moles, we set it up, we make sure our units cancel out. Same thing here. So I'm going to put what I have, my 12 girls. And then I'm going to put the ratio. Right? So if I want to get boys out, do you think I'm going to put girls on the top or on the bottom so that I can cancel out the unit girl? Right, I'm going to put it on the bottom. So I'm going to put my 2 girls on the bottom, and then therefore I'm going to put my 3 boys on the top. These units cancel. Oops. Girl, cancel. And I'm just left with boys, which is what I need. I need boys. So now that we know that our units are right, our math is probably going to be right too. So I'm just going to pop that straight into my calculator. So I have 12 times 3 divided by 2, which gives me 18. So we have 18 boys. Let's pop that here. Did you get it right? I hope you got it right. If you did not get it right, can you please rewind this and follow my steps? Because you need to know how to do ratios in order to succeed in today's lesson. Okay, let's get it. Let's erase all of this. Okay, so we know what a mole is, and now we know what a ratio is. So what is a mole ratio? So mole ratio is a ratio of moles of reactant to moles of product, and vice versa. So if you see here, We have the reactant over the product or the product over the reactant, just like how in our last example we had girls over boys and boys over girls. Does that make sense? So you're going to be able to do reactant to product and product to reactant like you did girls to boys and boys to girls. Cool? You'll see. Okay, so the mole ratio is found by determining the number of moles of product and the number of moles of reactant in the given problem. So this can be done just by looking at the coefficient of the balance equation. So just to make sure that we're all on the same page here, reactants are what goes in to the equation. So here, this is an equation. Glucose plus oxygen gives carbon dioxide and water. You should also know what this is. This equation is for respiration. You got it. Okay. So glucose and oxygen are going into the reaction, so they are called the reactants. Carbon dioxide and water are being produced by the reaction, so they're called the products. The subscripts you guys already know are the little letters that tell the little numbers that tells us how many of each element we have. The coefficient is here in green. It is the big number in the front, so it tells us how many of each molecule we have. And then the formula is showed to you in blue, but you already know how to do that because you've been doing empirical formula, molecular formula, all sorts of formulas. So are we comfortable with this? Good. Okay, so we're just going to hop right in it because I think this is the best way to show you what's going on. So let's do a mole ratio example. So according to the reaction, as you can see, C2H8 plus 4 oxygen gives us 2 carbon dioxides and 4 waters. So what is the mole ratio of C2H8 to water? So how do I need to set this up? I need to do C2H8 ... water. Cool. So how many C2H8s do we have? 1. Right. And how many waters do we have? 4. So it's going to be the ratio. Oops. 1 to 4. As simple as that. So let's do the next one. What's the mole ratio of carbon dioxide to oxygen? Well, first I'm going to write down carbon dioxide to oxygen. And then I'm just going to see how many there are. So it looks like we have 2 carbon dioxides because it gives it to me here in the equation. We got our 2. And then we have 4 oxygens. So I'm going to put that there. It is 2 to 4. But can we simplify that? I think so. Let's divide both sides by 2 so we get 1 to 2. Okay, let me just write it. So the answer is 1 to 2. Perfect. Okay, now you do one. So read this question, pause the video, try it yourself, and then I'll go over it. Pause. Cool, and we're back. So you have already done this and you have the answers in front of you, so I can just quickly go through it, right? Right. So it says, what's the mole ratio of sodium fluoride to magnesium fluoride? First thing we're going to do is set up our ratio. It should look like this. And then I look at my coefficients. So in front of NaF, there's a 2. So I'm going to put my 2 there. And in front of MgF2, there is no number, which means there's just one of them. So I put a 2 and I put a 1. I'm done. Next one, what's the mole ratio of magnesium to sodium? So we have Mg here. Oh, let me set it up first. Bang. So I have Mg here. There's no number, which means we have one of them. And then sodium is here. There's a big 2 in front of it, so I have 2 of those. So this ratio is 1 to 2. Simple, right? We got it. So you guys are going to spend the next few minutes completing the worksheet, well, these 2 questions on the worksheet below. So I want you to pause the video, complete these 2 questions below in your Google form, and then come back to the video so we can do the rest of the lesson. Cool. So now that we know how to find the mole ratio, we can put it to use so that we can actually convert between moles of one substance and moles of another. So the whole point of doing this conversion is for us to be able to calculate the theoretical yield. So the theoretical yield is basically just the amount that we calculated to be true. So the definition that is in your chemistry textbook says theoretical yield, read with me, theoretical yield is the quantity of a product obtained from the complete conversion of the limiting reactant in a chemical reaction. It's commonly expressed in terms of grams or moles. In contrast, the actual yield is the amount of product actually produced by a reaction. So let me put this in real world terms and then we'll look at the definition again. So let's say we're doing an experiment and I say I want you guys to make salt, table salt. So we know in order for us to make table salt, we need sodium hydroxide and hydrochloric acid. Cool. But I'm like, I need you guys to make me 3 moles of salt. I only need 3. I want it to be 3 exact. So let me just mark that on here. So the numbers that I write on top of here are going to be, let's do a pretty color. Let's do orange. The numbers on top are going to be the mole. So let's say I need 3 moles of NaCl. And then I use my research to calculate how much moles of NaOH and HCl I need. So I'm just going to make it up for right now just to prove a point. So let's say it says I need 2 NaOH and 2 HCl in order to make 3 NaCl. These numbers in orange would be the theoretical. Theoretical meaning this is supposed to hold true. Like if everything goes right, according to the math, this is it. Now, the actual yield in contrast would be, so I asked you guys to make me 3 moles. So you take your 2 moles of NaOH and your 2 moles of HCl and you mix them together. And then I go and I say, Ayana, how many moles of NaCl do you have? And then she says, oh, well, when I mix the 2, I only got 2.89 moles. So let's put that in. Let's put that in blue. So in Ayana's experiment, she got 2.9 moles by mixing 2 and 2. So this would be her actual yield. This is what actually happened. Does that make sense? And like somebody else can come along and say, well, shoot, I actually got 3.2 moles by mixing 2 and 2. And that would be another actual yield. So does that make sense? The theoretical yield is the yield that holds true based off of science, whereas the actual yield is what you actually get after completing the experiment. So what we're going to be doing in the next few slides is calculating that theoretical yield. So now that you know the mole ratio, we can convert from moles to moles so that if I say I need 3 moles of NaCl, you can actually tell me how much hydrochloric acid and sodium hydroxide I need. So let's just do it. Let's just do it. So I just put this map back up. You guys should have seen this before, but when we were going from moles to moles, so let's say moles of hydrochloric acid to moles of table salt, we're going to use that mole ratio. That's all this is showing you. Okay, so let's do this example. So this example is showing us how to convert between moles and moles using the mole ratio. Got it? Okay, so let's read it. So using the equation above, how many moles of aluminum are produced when 1.6 moles of aluminum chloride react? So what are we converting between? We're converting between moles of aluminum chloride and moles of aluminum, sorry. So there's only two things that we really do here. We are going to use the mole ratio to be able to cancel out units. And using that same method that we used in the beginning of this video with the boys and girls example. So let's just hop right into it. I'm going to start with what I know. So I know that I have 1.6 moles of aluminum chloride, which is here. So I need to make sure that I include my units always, or I won't be able to cancel them out and get my right answer. So this is what I know. What am I trying to find? I'm trying to find moles of aluminum, right? That's what the question's asking me. So I'm going to write that here. Now, how can I go from this unit, mole Al2Cl3, to this unit, mole Al? I'm going to use a ratio, right? So we need the mole ratio between the two. And how do we find that? Coefficients, right? So the ratio between aluminum chloride and aluminum is, aluminum chloride has no number, so it's 1, and aluminum has a 2 in front of it, so it's 2. So the ratio must be 1 to 2. Now, I can use this ratio to cancel out my units and get this aluminum on the outside. So, oops, I told you the answer, darn it. If I wanted to get moles of aluminum on this side of my equal sign, will I put the moles of aluminum chloride on the top or on the bottom? On the bottom, right? So if I put it on the bottom, I'll be able to cancel these two out. So the ratio is 1 mole of aluminum chloride to 2 moles of aluminum. So I'm going to put my aluminum on the top. And that's it. So as you see here, these can cancel. Let's scratch these out. So this mole of aluminum chloride and this mole of aluminum chloride can cancel out, which leaves me with just this, which is here. So I know my answer is correct. Now I'm just going to put 1.6 times 2 in my calculator, which you can do in your head. Oops. Is 3.2. And that's our answer. Simple as that. So mole ratio and then cancel out units. That's it. So as per usual, I'm going to ask you to pause the video and attempt this yourself. When I say pause, I really mean pause. You should have a piece of paper in front of you every time you watch one of these videos, okay? So I'll go over it after you're done. Pause me. Okay, so next we're going to set it up the same way. We need to find our molar ratio and we need to cancel out some units, and that's it. So let's start by writing what we have, because that's what I like to do. So we have 0.89 moles of magnesium oxide, which was given to me in the question. And I need to get moles of magnesium because the question also asked me to do that. So at this point, I'm just following directions. Next, I need the molar ratio. I need something to put right here so I can start canceling out my units. So we are comparing magnesium oxide and magnesium. So in front of magnesium, I see a big 2. So that's where I'm going to put it. That's what I'm going to put down here. And then in front of magnesium oxide, I also see a big 2. So my ratio must be 2 to 2. But can't that be simplified to something? Yes, 1 to 1. Cool. So 1 to 1 ratio. Next, I need to set up my equation up here so that I can cancel out units. If I'm trying to get rid of the MgO, am I going to put it on the top or on the bottom? On the bottom. And then I'm going to put my magnesium on the top. These should say 1 to 1, but it's the same thing. So I'm just going to multiply my 0.89 times 2 over 2, which is 1. So what's my answer? 0.89. Whoop whoop, you did it again. So this is it, my friends. You are going to complete these 2 examples by yourself on the worksheet below in your Google Doc, Google form. You actually don't need to pause the video because the video is just going to end. So I can just go ahead and delete this. But you guys got it. So if you're having any issues with these, I really recommend you looking at the question before I go over it, pausing it, trying it, and then grading it yourself, so you know where you went wrong. Cool. So this is it. You guys have been doing a really great job progressing through stoichiometry, especially since you're not in the classroom. So far, I wanted to celebrate what you've learned. You've done molar mass, percent composition, empirical and molecular formula, moles to grams, moles to atoms, and now moles to moles. Chemist. Psh. You probably are going to know more than me soon. But you also have an exit ticket at the end of this, okay? So after you finish those 2 questions that I just talked about, press next. It will take you to the exit ticket. And that's all. I'll see you guys later.